Hi guys, welcome to another video of physics. In this case, we're going to begin with this topic that is vertical throw. That is the continuation of the topic of free fall. Okay? Well, I just want to say that vertical throw can be divided in two types. Vertical throw that goes upwards and the one that goes downwards. Okay? But in this video, we are only going to see upwards, and several videos later, we're going to focus on the vertical throw that is downwards. Okay, so I'm going to begin with this one. So I'm gonna make the drawing. This is just the explanation. So imagine that there is a person over here, and this person is going to throw an object vertically upwards. So it's going up, okay? And well, I know that if you throw something vertically, of course, that object, removing the air and other factors, well, that object is going to return to the same place. But in this case, well, I need to make the drawing a little bit different so we can analyze the motion. So it's going to be something like this. Okay, and imagine that the object at this point is going to return to the origin, so to the same place where it was launched. Okay, so this is kind of the drawing. And with another color, I'm going to separate this motion into segments, and those segments are gonna be exactly the same. Okay, so I'm gonna do something like this. Oops. Okay, and I'm gonna say, oh, it's a little bit, it's not as straight as I wanted. Okay, yeah, something like this. And I'm gonna say that this is the segment number one. I'm gonna put it over here. This is the segment number one, and this is the segment number two. Okay, the segment number one is where the object goes up, and the segment number two is where the object goes down. Okay, so let's analyze this motion. Okay, at this point in the segment number one, when the object goes up, okay, at this point over here I got the initial position. Okay, here I have initial position, and most of the times that initial position, and I'm gonna be called this initial position of the segment number one, and most of the times is 0 meters. Okay, sometimes the problem, they don't mention the height where this object was launched, so we're going to assume that that initial position is 0, and we're gonna have initial velocity of the segment number one. Now, for example, I don't know how much is this velocity, but if you remember free fall, the initial velocity was always 0. Okay, that's the main difference in here. In vertical throw, the initial velocity is not 0 anymore. So the initial velocity in this case, well, is gonna have a value, and that value will be positive. Okay, because remember the reference system, everything that goes up, I'm gonna throw it here, everything that goes up is positive, everything that goes down is negative. Okay, so I got the initial position, I got the initial velocity of the segment one, that is going to be a value, and it's going to be negative. Sorry, it's going to be positive. Of course, I'm going to have the gravity acceleration, that is the value of the gravity, that is minus 9.8 meters per second square. So that means that during the time, this time, okay, the velocity of the object is going to be decreasing because of the effect of the acceleration, because it's negative. This sign over here tells me that the direction is negative of the acceleration. So that acceleration will be decreasing the velocity. So imagine that you throw the object with 5 meters per second. So 4, 3, 2, 1, 0. Okay. So at the highest point over here, okay, that, okay, I'm going to draw something like this. In this point, I have my final position of the segment 1, okay, and that is the maximum height. Okay, at this point. Also at that point, I got the final velocity of the segment 1. Now, it's like a law or something that the velocity at the highest point is always 0 meters per second, or 0 kilometers per hour, or 0 as you wish, but it's going to be 0. So final velocity of the segment 1 is going to be 0 meters per second. Okay, but you can write that. Okay, we can write. I'm gonna write it with another color. Velocity in maximum height is always 0. Okay, and this is the concept, like I say, the concept number 1, because we're gonna have many other notes, important notes to write. So this is the first note. Okay, so we've got the initial position, the initial velocity, the final position, the final velocity. We've got the acceleration, and also we're gonna have the time that takes the object to reach the maximum height. So that time will be time 1. Okay, time 1, because it's the time of the segment 1. Okay, now let's go to the segment number 2. In segment number 2, if you see the object is here, and from this point it's going to be falling, and it's going to reach the same place where it was launched. So if you see, the object is going to be falling, so the segment number 2 will be treated as free fall. Segment number 2 is going to be free fall. That is the previous topic that we already saw. Okay, so in this point, remember, this is the segment number 2. In the segment number 2, this is the beginning of the motion. So that means that is the initial position of the segment 2. And that initial position of the segment 2 is the maximum height. Okay. It is the same as the segment number 1, but if you see, the variables are not the same. This is the final position and this is the initial position, because they are different. In this case, the final position is where the stone or the object ends the travel, finishes the travel or the path. And in this case, it's about to begin the path. That's why it's initial position. Also, at that point, I'm going to have the initial velocity of the segment number 2. And the initial velocity is the velocity at the highest point, so it's going to be 0 meters per second, because I already wrote it here as an important note. Okay, now at this point over here, well, I'm gonna have the final position of the segment number 2, that is going to be 0 meters. Okay, most of the times it's going to be 0 meters. Okay, just exactly the same as the segment number 1, but just make the difference that this is the initial and this is the final. Okay, also I'm gonna have the final velocity of the segment number 2. In this case, just as free fall, is going to have a value, and that value is going to be negative, because in this case the object is going to be falling, and everything that goes down is negative. Now, the second note that I'm going to write here is that the initial velocity of the segment number 1, this velocity over here, is the same velocity of the segment, the final velocity of the segment number 2. They are the same, but they are opposite. Okay, so if the object has 5 meters per second, okay, it's going to return with minus 5 meters per second. I repeat, the velocity is going to be the same, but with opposite sign, because in the beginning it's going up and returns going down. Also, in the segment number 2, we got the acceleration, that is the value of the gravity, that is minus 9.8 meters per second square. And also, I'm gonna have the time that take this object to reach the initial position where it was launched. So I'm gonna have time 2, the time of the segment 2. Now, another note is that the time 1, the time of the segment 1, the time that takes the object to reach the maximum height, is the same as the time 2, the time to takes the object to reach the place where it was launched. And number 4, if you want, total time. Okay, the total time, so it means from this point to this point, the total time, well, it's just the addition of those two times, time 1 plus time 2. Okay, so this is kind of the theory of the vertical throw. If you see, I separate the motion in 2 segments. When we solve problems, we can work with the segment number 1, or we can work with the segment number 2. It's up to you, but we're going to see that in the next video, where I hope I can see you over there, guys. Okay, well, that will be all for today. Bye bye, guys.